Hi dear students, how are you? I hope all are fine. Okay, in the previous class we discussed about quantum numbers. Once let me recall quantum numbers. Okay, I will give one example, then you will understand clearly about quantum numbers. Okay, see, for example, now we are in one college. Once you have to imagine, now the college compound wall is shell or orbit. Once you have to imagine. Okay, now about shell or orbit, which quantum number can explain? Principal quantum number can explain about shell or orbit. Okay, now once you have to go inside the college, then our room will come. Now here our room is nothing but subshells. Okay, it is a subshell. Our room is subshell. Now about subshells, which quantum number can explain? That is azimuthal quantum number. Okay, next we have to go inside the room. Then we will see benches. These benches are nothing but orbitals. About orbitals, which quantum number can explain? That is magnetic quantum number. Now inside the benches, who will sit? Students will sit. Here students in the sense electrons. Now about electrons, which quantum number can explain? Spin quantum number. Have you understood clearly? Here simply first compound wall is nothing but shell or orbit. Next our room is nothing but subshell, and bench is nothing but orbital, and students are nothing but electrons. Have you understood? Here simply college compound wall is nothing but shells or orbits. About shells or orbits, principal quantum number can explain. And if you go to inside the college, then our room is nothing but subshell. About subshell, orbital quantum number can explain. I mean azimuthal quantum number can explain. Okay, and inside the room benches are there. These benches are nothing but orbitals. Now about these orbitals, magnetic quantum number can explain. Now in the benches, students can sit. These students are nothing but electrons. Okay, about electrons, spin quantum number can explain. This is the clear cut clarity regarding quantum numbers. Have you understood? This is simply about quantum numbers. Okay, now today let me explain energy of shells or orbits. Already we know the energy of shell or orbits order is K, L, M, N shell and so on etc. Okay, it means the shell which is present near to the nucleus have less energy, and the shell which is far to the nucleus have more energy. This point I have to remember. K shell is near to the nucleus, so it have less energy. N shell is far to the nucleus, so it have more energy. Now the order is K, L, M, N shell and so on etc. Okay, next let me explain about energy of orbitals. Now see, here it is the atom, one of the atom. In this atom, this is nucleus, K, L, M, N and so on, so many shells are there. It is also called first shell, second shell, third shell, fourth shell. Okay, now in these shells some subshells are there. What are they? In K shell, S subshell is there. In L shell, SP subshells are there. In M shell, SPD subshells are there. In N shell, SPDF subshells are there. Okay, again in that subshells orbitals are there. See what are they? In S subshell, first 1s orbital is there. Okay, here why 1s? Because it is first shell, it is S orbital. So 1s orbital. In S subshell, 1s orbital is there. Next, in L shell there are two subshells. In that subshells again orbitals are there. What are they? Those are 2s orbital and 2p x orbital, 2p y orbital, 2p z orbital. Okay, this point I have to remember. Now here simply I have to remember, in s orbital 2 electrons can fill, in p orbital 6 electrons can fill, in d orbitals 10 electrons can fill, in f orbitals 14 electrons can fill. Okay, now here see, in third shell there are 3 subshells. In that 3 subshells again orbitals are there. What are they? 3s, 3px, 3py, 3pz and 3dxy, 3dyz, 3dxz and 3dx square minus y square, 3z square. Okay, so like that this fourth cell also same. Now the order is 1s is less than 2s 2p is less than 3s 3p 3d less than 4s 4p 4d 4f and so on etc. Okay, here how can you know the energy of orbitals? We can know the energy of orbitals by using n plus l rule. Okay, see what is n plus l rule? N plus l rule in the sense by using n plus l rule we can know the energy of orbitals. Okay, see here n is equal to principal quantum number or stellar orbit number, l is equal to azimuthal quantum number or angular momentum quantum number. Okay, see the lower the value of n plus l value for an orbital, then the lower its energy. If the orbital n plus l value is lower, then its energy also lower, and similarly if the orbital n plus l value is higher, then energy of that orbital also higher. See, that is n plus l value of orbital is more, then orbital energy more. N plus l value of orbital is less, then orbital energy also less. This point I have to remember properly. Okay, now let me explain some problems regarding n plus l value. See, calculate the energy of 1s 2s orbitals and write the increasing order of energy of 1s 2s orbitals. Okay, see, now 1s orbital n plus l value I want to calculate. Here 1 in the sense n value. Here l value of s orbital we know. L value for s orbital 0, L value for p orbital 1, L value for d orbital 2, L value for f orbital 3. Now here n plus l value of 1s orbital I want to calculate. N value 1, L value for s orbital 0. So 1 plus 0 1. So 1s orbital n plus l value 1. Next 2s orbital n plus l value I want to calculate. See, n value is 2 and l value for s orbital 0. 2 plus 0 2. It means 2s orbital have n plus l value is 2. Have you understood? Here which is more, 1s have less n plus l value and 2s have more n plus l value. See, according to n plus l value, which orbital have more n plus l value, that orbital have more energy, and which orbital have less n plus l value, that orbital have less energy. So according to that rule, 1s is less than 2s. It means 1s have less energy than the 2s. Have you understood? Similarly, you have to calculate for 2s and 2p. 2s n plus l value, n value 2, l value for s orbital 0, 2 plus 0 2. Okay, next 2p, n value for 2p is 2, l value for p orbital 1, 2 plus 1 3. Now here which one have more n plus l value? 2p have more n plus l value, so 2p have more energy than the 2s. Next, this case I have to see, this is very important. See, 2p 3s n plus l values I want to calculate. Now first you have to calculate n plus l value for 2p. See, here n value for 2p orbital is 2, l value for p orbital is 1, 2 plus 1 3, and 3s l plus l value I have to calculate. Here n value for 3s orbital is 3, l value for s orbital is 0, 3 plus 0 it is equal to 3. Now here this is the problem, both the orbitals have same n plus l value. Now how can you say which orbital have more energy and which orbital have less energy? This is the problem here. To rectify this problem, here one rule can helpful. That rule is this one. In this case, the orbital with lower value of n will have lower energy. It means simply which orbital have less n value, that orbital having less energy. Which orbital have more n value, that orbital have more energy. In this case, which case? If the both orbitals having same n plus l value, then only this rule can applicable. Okay. See, now 2p and 3s, which one have less n value? It is n value. Okay, 2p have less n value, 3s have more n value. So 2p have less energy, 3s have more energy. Now the order is energy increasing order is 2p is less than 3s. Have you understood? So in the same way, how to calculate the energies for 3s 3p, 3p 3d, 4p 4s, and 3d 4s. I will explain this one how to see. 3d n plus l value. Here n value 3 and l value for d orbital is 2. Okay, totally 5. Next 4s, n value 4, s orbital, l value 0, 0, 4 plus 0, 4. Now here 3d orbital have more n plus l value. It means 3d orbital have more energy than the 4s. Have you understood? Now this is simply about n plus l rule. Okay, okay, now let me explain Aufbau principle. What is Aufbau principle? See, the electrons are filled in the orbitals in the increasing order of energies of the orbitals. Okay, see, simply electrons can fill in the orbitals. How it will fill? Which orbital have less energy? In that orbitals electrons can enter first. Okay, this is called Aufbau principle. Have you understood? See, it means among the available orbitals, the orbitals of lowest energy are filled first. Okay, which orbital have less energy, that orbital can fill by the electrons first. Okay, see, next n plus l value of orbital is more, then energy of orbital also more. N plus l value of orbital is less, energy of orbital is also less. Already we discussed this one. If two orbitals have same value of n plus l, then the orbital having lower n value is first filled. Okay, this also we discussed already. Okay, see, next the increasing order of energy of different orbitals is as follows. One order is there. After calculating the all n plus l values of all the orbitals, then final order is 1s is less than 2s is less than 2p is less than 3s is less than 3p is less than 4s is less than 3d is less than 4p is less than 5s is less than 4d is less than 5p is less than 6s is less than 4f is less than 5d is less than 6s is less than 7s is less than, and so on etc. Okay, this is simply about Aufbau principle. Now this order we can understand by using one special diagram that is called Moeller diagram. Now let me explain about Moeller diagram. Okay, now let me explain about Moeller diagram. What is Moeller diagram? Simply it is the diagrammatic representation of filling of electron in the orbitals according to Aufbau principle. Okay, by using this diagram we can understand clearly how the electrons can fill, in which orbital electrons can fill first and in which orbital electrons can fill last. Okay, we can know very perfectly by using this Moeller diagram. Moeller diagram arranged by the increasing order of n plus l value. This point you have to remember properly. Now see, 1s orbital, 2s orbital, 2p orbital, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6s, 6p, 7s. Now you have to write like this. Now arrows you have to keep like this, crossly. Okay, now here 1s orbital, these are all s orbitals. These are s orbitals having l value 0, s orbital l value 0, p orbitals l value 1, d orbitals l value 2, okay, f orbital l value 3. Have you understood? Now it is first shell, 1s orbital is there. In second shell, 2s 2p orbitals are there. In third shell, 3s 3p 3d orbitals are there. In fourth shell, 4s 4p 4d 4f orbitals are there. In fifth shell, 5s 5p 5d orbitals are there. Sixth cell, 6s 6p still there, but up to here enough. Okay, seventh cell, 7s orbital is there, still there, remember. Okay, now the electron first can enter into 1s orbital. After filling the 1s orbital, I mean s orbital capacity how much? S orbital capacity 2 electrons, p orbital 6 electrons, d orbital 10 electrons, f orbital 14 electrons. Okay, so first electron can enter into 1s orbital. After filling of 1s orbitals fully with 2 electrons, then the next electron will go to 2s orbital. Okay, after filling of 2s orbital fully, then next electron will go to 2p. After filling of all the electrons in the 2p, the next electron will go to 3s. Okay, like that step, like this, in this manner arrows are there. The arrows representing position is there. In that position, in that way electrons can fill. In the arrows position the electrons can fill. Okay, have you understood? Here you have to remember one thing. All s orbitals capacity only 2 electrons, whether it is 1s or 2s or 3s or 4s or whatever it may be. S means only 2 electrons capacity. All p orbitals capacity is 6 electrons. whether it is 2pr, 3pr, 4pr, anything, but p orbital means that is 6 electrons, d orbital means 10, whatever it may be the orbital, like 3d or 4d or 5d. Okay, f means 14. In that way I have to remember. Okay, this is simply about a Moller diagram. Now let me explain on an example. For example, now I have 3s and 3p orbitals. These two orbitals I have. Okay, and I have 3 electrons. Okay, now these 3 electrons I want to fill in these two orbitals. According to this diagram, now I have to see 3s, 3p. First 3s can fill, so 3s should fill with 2 electrons because s orbital capacity 2 only. So 3s2 and remaining 1 electron is there. That electron will go to, after filling of 3s, that electron will go to 3p. So 3p1. In that way, electrons can fill in the orbitals by using Moller diagram. One more example I have to see. For example, 4s comma 3d. Okay, for example, 4s comma 3d orbitals are there. Now I have 5 electrons. Now where are the 4s and 3d orbitals? Here and here. Okay, see, now here 4s orbital can fill with only 2 electrons. After remaining 3 electrons are there, that 3 electrons will go to 3d. After filling of 4s, the electrons will go to 3d. See, now 3d 3. Okay, this is the filling of electrons in the orbitals by using Moller diagram. Have you understood clearly? Okay, this is the today's class. If you like this video, then press the like button and please subscribe my channel. Thank you. All the best.